Okay. Good morning, everybody. My name is Richard Bishop. I'm your moderator for this session.
Do we have the clicker?
Thank you very much. Aha. And I'm looking for my slides. Why? How did we get there? There we go. Welcome. This session is titled "Sharing the Road with Driverless Trucks." Really? We're going to talk about that. It's kind of a wild idea in some ways, and yet it's current. Things are going on. We have two excellent speakers with us today. Is there a reason I keep losing my... We have Vijay Patnaik of Waymo, the truck side of Waymo today, product lead, as well as Chuck Price of TuSimple. Thanks for being here, guys. Chuck is head of product for TuSimple. We'll hear from both of them. The program, I believe, still says that we had a third panelist who unfortunately had to cancel. That was Annie Lean, a renowned consultant in this space, very present person in Silicon Valley. She was a consultant in this space back when we applied for the session, and she got a real job with Toyota Research Institute. And congratulations to her. She's doing some very cool stuff there, but it's not truck stuff. So I'll give a bit of an introduction, and then we'll hear from these other two guys. But first, I want to get a little feeling from you all about this topic in general. And I'm gonna ask you three questions more or less. And here's how I want you to respond. You know, make a little right angle with your hand. And this means a lot, this means a little bit, and just nothing means nothing. My first question is, how much do you hate trucks on the road? Whoa, okay. How much do you love the idea of driverless trucks on the road? Wow.
Oh.
Standing up over there. Okay, the flip side, how much do you hate the idea of driverless trucks on the road? That's very interesting. I'm, a smattering compared to the others. So I guess we can say South by Southwest is full of sort of tech-forward people, but that's a good sort of metric for us, a calibration. So let me give you this perspective, starting obviously with the Berlin Wall, 1989. Why am I putting that up there? Well, Berlin Wall came down in 1989, and what happened was there was a peace dividend. Money that used to go to defense started going to civilian purposes, and this actually has a link to our world. So one of the things that was created by Congress within US DOT was called the Automated Highway Systems Program. And the aim was to develop this kind of technology. Interesting, nobody talks about an automated highway system anymore. But the thinking then was maybe there needs to be some intelligence in the highway. That idea went away really quickly. So things happened. You can look it up on the web. We did a major demo in 1997. We worked with General Motors and Carnegie Mellon, UC Berkeley. It was very cool, but that's not the point of why we're here. It's to say that there was a lot going on back in those days. I actually rode in my first driverless truck in Germany in 1999. It was a program called Chauffeur that was funded by the European Commission and led by Daimler Trucks and several other truck OEMs. So this is when engineers really got into this space, was during the 90s. There's been a cadre of engineers working this, computer scientists working this for all of that time, and even a lot prior. And it's interesting, these things, you can trace the lineage from these and other activities into what's happening today. So it's important to have that perspective. I think also we need to look at where we are in 2019. You know, that truck I showed you was 1999. Here we are 20 years later. You know, what happened between then and now? Well, the previous activity was funded by public money primarily, and that's fine. Now it's all about private money. It's all about commercialization. It's getting beyond prototypes that worked quite well as prototypes, but it's a whole other story to take it to commercialization. That's where we are now. So to give you the broadest context, there's 3 domains of automation. I think it's important to understand what these are. First of all, there's passenger cars, of course, as we've always known them, personally owned passenger cars. Privately owned, very low utilization. They're sitting, going nowhere most of the time for the average person. But that's an important market. The car manufacturers are all about that market. But there's some new players now. Robotaxis, of course, have come along, started by Google, which became Waymo. There are a lot of players in the space. That's a fleet operation, which means you can have engineers recertifying that vehicle every day. Whatever you need to do, the risk is lower in terms of introducing a capability. Plus, the cost pressures are not so much as a retail car purchase. And then the third area is what we're talking about here. Heavy trucks, very high utilization. It's a fleet operation. It's not about the cost of the vehicle. It's about return on investment. So you have a very interesting space there. And also there's some key synergies between these. There are car manufacturers that also make trucks. So their automated driving software can flow between. There are car manufacturers who are now into the robotaxi space. And so that can play back and forth. The robotaxis have become the incubator for this technology for car manufacturers, eventually taking it to the mass market. And then you have startups like Waymo that is doing both robotaxi and truck. So as you can imagine, there's some interesting things going on. So to get more into the truck industry world, it's a very big world. You might hate them, but whatever's in your hand, whatever's in your pocket, whatever's in your bag was on a truck at some point. I can virtually guarantee it. You know, we know that. It's out there. Kind of if you hate trucks, it's a necessary evil, but it's also essential. Very big industry in terms of revenue. The profit margins are very thin, on the order of 3%. The pressures are tough. There are a lot of pain points in this industry. I could go on, so I won't go through all of these. But we have, in particular, those first two on the left. Fuel cost is huge, and the labor costs are huge. Safety is, of course, a key area. And there is a driver shortage out there that is very difficult. It was seen as a drastically terrible driver shortage about 10 years ago, and it gets worse every year. So that's very much part of the context for what we're talking about here. So we do have driverless trucks today. Trucks that are sitting parked because there are no drivers to pull that load anywhere. There are a lot of driverless trucks like that. So let's see if we can improve upon that a little bit. Safety, there's good news, very, very good news in the safety domain for cars, trucks, whatever. There's a lot of safety equipment on vehicles now. More and more trucks every year, hundreds of thousands of them have some sort of radar-based automatic emergency braking and other things that make that a very safe vehicle. At the same time, we know that crashes still happen. And it's important to know that the way you bring automation into the market is to start with the simplest environment possible and move on from there. So if you're not aware, there have been trucks in strip mines in Australia for 5 years or so at least. It's a very simple environment. The corporation that runs it controls everything about that environment. That's great. That's low-hanging fruit. And now we're stretching out into the public road environment where, as these guys will discuss, you're still going to see some limiting of the risk and complexity. So what about the jobs issue? If you've read anything about this, you'll see a lot of opinions about jobs going away, a disaster in the job world. I think it's a lot more nuanced than that. And you have to think about automation in general over time. Jobs evolve. When was the last time you saw an elevator operator in an elevator? 100 years ago when elevators were new, the public was scared of them. I mean, it's going very high, and what if it breaks and you plummet to the bottom? And that was part of the reason for elevator operators originally. A few decades went by, and suddenly, people were saying, what's the point? And elevator operators, went away because the technology evolved a bit. There's a lot of situations, a lot of things like that. I don't want to trivialize the issue. And in fact, I want to recommend to you, if this is an important question to you, this report, which I think is one of the best reports published to date, called America's Workforce in the Self-Driving Future, published by a group called SAFE, Securing America's Future Energy. And it was led by Dr. Erica Groschen, who is a Harvard economist and formerly leading the Bureau of Labor Statistics. So this gets into a lot of nuance. The bottom line being that the impacts of driverless trucks will probably occur over about 20 years. The impacts on jobs will be less than a mild recession, was the way this was talked about, and to plow the benefits from this technology into the retraining, the sort of things that society does in general. The market evolves and absorbs these kinds of things. So another couple of things I want to touch upon in the regulatory space. Of course, that's a long, geeky discussion. I won't say a lot, but the federal government has published what's called the Federal Automated Vehicles Policy. 3 versions now, and version 3.0 just came out in October. And remarkably, the headline from that was that the federal government says you can run driverless trucks on the roads. Go for it. And that was important because the federal regulations get deeply into what's called hours of service for drivers and lots of things that drivers do. And the Fed said, nope, that doesn't apply to driverless trucks. So that really opens up this market, and the U.S. is by far in the lead in terms of the feasibility of bringing something to market because of that. It's complex in some other ways, but we have that. So, and the last slide I want to offer to you is ripe tomatoes. When you think about trucking tomatoes, any kind of fresh produce now, and this is just one example of the way freight can evolve in so many ways. But it takes 5 or 6 days for a load of tomatoes to come from California to the East Coast. Partly, hugely, because the drivers have only so much driving time and they have to rest, etc. If that truck can go nonstop, driverless, just stop for fuel, maybe 2 days. And what does that mean? Now, I'm kind of speculating here, but I think it means that you don't have to pick the tomatoes when they're green. You can pick them when they're kind of red and then ship them. These are the sorts of things that are going to filter through. I'm not the expert to figure that out, but things are going to ripple through when you don't have that need to pay a driver in the front seat. So with that, I'm going to shift over. I think I'd encourage you to consider that, and I really want to stress this, the truck drivers of the world, I know lots of them, they are very, very professional people. They've got their act together in general, but there's a lot of them, and they're people, so of course sometimes they're not great, sometimes they're not driving when there should be. So as you listen to our speakers and our discussion, consider, who would you rather be driving next to on the road? If you're driving next to a driverless truck, well, this is a new thing, and you don't know what it might do. You have no experience with it. But of course, if you're driving next to a manned truck on the road today, you don't know what that human being is going to do either. Could be great, probably great, but you don't know. So you've got some not knowing either way. And it's a question of what kind of world do we want to live in. So with that, we will shift over to Vijay. Vijay and I got to know each other last year at the Automated Vehicle Symposium. Had some great discussions and a breakout on truck automation. And you've been with Google for quite a while. Google for starters, and then into this space. So with that, I'll turn it over to you. Thank you.
Thanks, Richard. My name is Vijay Patnaik. I'm a product lead at Waymo. Excited to be here to give you a bit of an intro of what Waymo is doing, and that'll be helpful context as we dive into the panel questions later. So Waymo is a self-driving technology company with a mission to make it safe and easy for people and things to move around. So I'll explain a little bit more of what we mean by that. But first, let's talk about the different levels of autonomy, just to make sure we're all talking the same language. So what does it mean when we say fully self-driving trucks? The Society of Automotive Engineers has put out a helpful scale to contextualize this. The first 3 levels, levels 1 through 3, is what are driver assist technologies. This is when a human being needs to be in the vehicle on the driver's seat and paying attention. So when Richard was talking about safety increasing in trucking through usage of cameras and radars, what we have today is level 1 through level 3 technology, where the driver is attentive and paying attention the whole time. When we get to level 4 and 5, that's when interesting things happen. You no longer need a human being in the vehicle at all. What it means is, in case of cars, it means an empty car could come and pick you up. In case of trucks, it means a completely empty truck could be driving down the highway. So that's what we mean when we say fully self-driving vehicles. And this is what Waymo has been focused on throughout its history, is level 4. So to give you an idea about our history, Waymo has been working on this for nearly a decade. This started in 2009 after the DARPA Grand Challenges, when a few members from those DARPA challenges met with the Google founders to start this project, and it was born as the Google Self-Driving Car Project, and about a couple of years transitioned to being named Waymo and becoming a separate entity. Over those years, we've been working on building self-driving vehicles on a variety of different platforms. The current one that you will see most commonly is a Chrysler Pacifica minivan, as well as our Class 8 trucks. We've collected over 10 million miles of driving because we believe experience is the best teacher, and we've been continuously improving our system along the way. While we've worked on this technology over many years, Waymo, as it's with every other company, has been testing with a trained driver on the driver's seat, monitoring the car at all times. However, in October of 2017, we took our first steps towards testing with nobody on the driver's seat. And let me show you a video of what that looks like. Just press the start button and the car's doing everything else, figuring out the right route to take, which turns to make, when to yield to pedestrians and other cars. All of the driving decisions are made by the car itself. So that's what fully self-driving cars look like. This wasn't a one-time ride or a demo. This was the start of a new phase of testing for Waymo and for the history of this technology. So we continue to test our vehicles in a mix of configurations, fully self-driving as well as with trained drivers as we develop the technology. Members of the general residents and members of the public in Phoenix, Arizona have been using our cars as well. They take it for their everyday commute to work, for going to the gym, or for picking up groceries. And towards the end of last year, we introduced a commercial service called Waymo One in Phoenix, Arizona. So that brings us to trucks. At Waymo, we're focused on building a driver, and that driver can learn to drive different vehicles, and that's where Class 8 trucks come in. In 2017, we started using all of the self-driving technology that we had developed. We started by putting it on Class 8 trucks. So these are the trucks the heavy-duty trucks that Richard talked about. The goal there was to adapt our technology to work with these vehicles, and not just for testing. We've also actively done pilots. So this is a picture from a pilot that we did in Atlanta, Georgia, where we were actively carrying freight for Google's own data centers. These kind of pilots help us learn what it takes to integrate self-driving technology into commercial operations of a fleet. And for the fleet, it's very beneficial for them to learn how self-driving trucks could benefit their operations. We've done hundreds of runs in Atlanta, and that has influenced our technical roadmap as well as how we work together with fleets. To ensure safe deployment of these trucks, we use a variety of testing methods, from real-world miles to simulation, as well as structured testing, which is testing on private tracks where we have the ability to create difficult scenarios and see how our vehicles would behave. I'm excited to talk about this further as we dive into some of the questions in the panel, but I'll stop here for now.
Okay. Thank you, Vijay. You know, from my perspective, when I was leading the government work back in the 90s, we could not have dreamed of vehicles that look the way yours do, you know. But of course, things have come a long way. So now we'll turn to you, Chuck. We met when you first entered the automated vehicle space a few years ago, and prior to that, you've had a lot of varied experiences in the tech industry. He's a great storyteller. Let me just say, if you can sit down next to Chuck in a bar, you're going to hear some good stories. So with that, we're going to see some good stuff and hear some good things about TuSimple. Please go ahead.
Thanks, Richard. So this is our self-driving truck, or at least one variant of it. We are building a fleet in Arizona, which I'll talk about in a bit. But let's first... Oh, it didn't quite come off with the fonts the way I thought it would, but that's okay. Let's put some context into what we're talking about here. In the U.S., in the last data that I could find on a government website was 2016. There were 475,000 truck-involved accidents in the United States. Now, to put that into context, there's only about 165,000 miles of highway in the United States, all highway. So this is a lot of accidents over the period. More significantly, is about 90% of these accidents are human caused. So, you know, the other 10% are meteors, space aliens, and, you know, whatever. So who is TuSimple? We are a global self-driving truck company. We are focused exclusively on trucks. Our technology was developed with trucks as our intentional deployment platform, so we've made a number of decisions that are specifically about trucks. We are global in that we have our U.S. headquarters in San Diego. We are not a Silicon Valley company. You can ask me about that later, why that's the case. We also have a headquarters in Beijing. These are the two top trucking markets in the world, and we intend to capitalize on both. We do our U.S. Production development and test in Tucson, Arizona. Can I see a show of hands? Anybody from Tucson? One. Well, I saw one hand up. That's amazing. So we'll talk later. We are about 400 employees, and by June we will have 50 autonomous trucks on the highway system between Arizona and Texas. So we're actually actively mapping routes today in Texas, and we'll be deploying. In fact, you're going to hear some news in the next few months about our expansion here. We do what we call depot-to-depot self-driving trucks. This is not just on the highway. This is from the parking lot of the departure facility to the parking lot of the destination facility. There is no, keep the driver in the back of the cab sleeping while you're, getting there so you have somebody to drive the truck when you get off the highway. This is full operation. So, since it's South by Southwest, we're going to show a lot of video, and you're just going to hear me talking. There's some annoying music playing in the first video. Feel free to get up and dance. This is a 6.5-minute video that I cut down for this talk. I just cut out some of the boring stuff because a lot of truck driving is boring. But you're going to see us driving through the worst parts of Tucson. So the one individual in the room who's from Tucson will recognize these roads. We chose to go through the hard part of the city rather than going outside into the open desert where it's easy. But we made another choice to do this in a storm. And they have big storms in Arizona. When they rarely have any rain, but when they do, it's a big deal. And they're big storms. So you're going to see us doing a full self-drive in a storm. This is from a GoPro mounted right behind the driver and the safety engineer. It's going to be run at very high speed, so I'll try to quickly interject what you're seeing as we go. Here we go. Negotiate those. It's hard to tell at high speed. Okay, there's about 17 minutes of that. Okay, here we're coming to a turnaround. the negotiation there. We'll cut a little bit more. You can get on YouTube. Okay, that's video number 1. So you can go to the TuSimple channel and see that video. I'm going to show you a view from inside the vehicle, what the computer is perceiving about the environment. And in this particular case, the truck has to execute a maneuver because there's a vehicle which happens to be a police car and another vehicle in the breakdown lane. And the rules are for heavy trucks, you should change lanes so you're not riding in the right lane when you blow by them and knock everybody off their feet, or you should slow down if you can't change lanes. This is a video showing that maneuver. You're also going to hear, so this is our human interface inside. I've overlaid some other video so you can see what's going on, and some text that isn't on the original HMI. You're also going to hear our safety engineer periodically through this talking to the driver. We always have 2 people in the truck.
We have detection over 600 meters.
Okay, so there is a vehicle in the breakdown lane. It knows it.
Tagging that.
That female voice you heard was the computer telling the driver that it's going to make a left change. Now you can see the LiDAR. So most of that detection was done by cameras.
By merge and avoidance. Will not be doing it until after merge and avoidance.
So most of that detection was done by cameras. As the vehicle got close, we got close enough to be able to also see it with LiDAR, which is laser ranging. And we were able to get a second signal on those vehicles. The third video I'm going to show is short. It's a little controversial in my company. My PR person said, please don't show this video, but I'm going to show it. This is a case where we made a decision to disengage. This was because of a bad actor near us. This was a bad driver. Remember the on-ramp merge that I said was very complex before, with 2 lanes going to 1, going onto the highway? This is the same spot. With a bad driver in the way. We have a policy in our company that we disengage when we think a situation is getting risky, because this is the open highway. These are civilians that we're testing around. We do this kind of testing when we do it on a test track. So we don't look for volunteers to be guinea pigs on the highway. So the safety engineer and the driver are trained. When they see it's getting intense, they just disconnect. We also disconnect if there are emergency vehicles like ambulances or such. So this is a quick little clip, and you'll see how this unfolded.
I'm looking for target rear. Got target rear. Non-compliant. Please disengage.
Autonomous driving off.
10-4. That was non-compliant. I have that tagged.
Okay, and so from that we have a really nice data set that we analyze and understand, whether we could do anything better. In this case, we don't think so, but that will be heavily analyzed. So that's TuSimple.
Okay. Thanks, Chuck. Thanks, Vijay. A hand for these guys. We're going to have 10 minutes of some back and forth discussion here at the table, and then we'll reserve 15 minutes for your questions. So So please keep that in mind. So clearly the tech works pretty good. What does it mean when we talk business, when we talk moving freight, when we talk the players out there? What kinds of freight, what kinds of fleet operations make sense for this kind of technology? Chuck, can you start on that?
Yeah, so these are trucks that are operating on a previously mapped route using a high-definition mapping technology. And so it mostly works well for fixed, well-defined routes that are fixed, repeatable,
repetitive, yeah, right.
Yeah.
Mm-hmm. Okay, that makes sense. Anything to add?
Yeah, and in terms of, I think it must be clear from the videos themselves, but freeways obviously will be the first use case for trucks. That's where a lot of miles are driven by trucks anyway. And as Chuck showed in his video, routes where there is a warehouse or a manufacturing facility pretty close to the freeway would probably be the first deployments we will see of this technology.
Mm-hmm. Okay, right. Yeah, there was mention of this hub-to-hub model, which some of the companies are pursuing. There are about, haven't counted lately, about 6 or 8 companies out there pursuing this. Several of them just came out of stealth in the last 3 months, so it's a very active space. But the idea of hub-to-hub is that because, remember the mining truck in Australia, because the highway is simpler, there's a business case or a business argument to be made that, hey, let's start there and only do highway, but then you have to get that load from the distribution center to the highway with the human, and that's sort of a in-between area. Different companies are doing it different ways. But Chuck, what kind of led you guys to your approach?
So we looked at the highway-only model, which many are embracing, and realized that for a fleet who's operating vehicles or a shipper who has a fleet of vehicles, highway only means you have to solve from the depot itself to the highway, and you have to do that with a human driver, and you either have to then, when you get to the highway, have that human driver, relinquish control and go sleep in the back or whatever, or you have to figure out a way to transfer the load to an autonomous vehicle. And so there are some companies that are talking about transfer hubs, where they basically have a giant parking lot near the highway where the manually driven vehicles meet the autonomously driven vehicles and somehow they match up. We felt that, in theory that might work, but in practice, if you've got a shipper that's releasing 100 trucks, that means they have to meet another 100 autonomous trucks, and it becomes a port. You've built a port next to the highway with thousands of trucks potentially. So we thought it's actually an easier problem to solve solve the surface street problem.
Yeah. Anything to add, Vijay? Yep. Okay. For the customer, that's how the customer works now.
Yeah.
So if you can match their current operations, you're good.
Yeah.
But it's a harder job.
It is a harder job.
Before I want to get into some of the tech aspects, the safety, professionalism, even the AI. But first, since it always gets asked, Chuck, you want to comment a little bit on what's the timing of these things being on the road? When might we see the beyond testing into commercialization? And I know these are companies with proprietary plans. We can't expect a definitive comment, but what can you say?
We try to be as transparent as we can.
Good.
So we are actually working with 13 globally recognized shippers. I can't mention their names because they asked us to keep it confidential, but you would recognize their names. We're shipping for them today. We've been shipping for them autonomously since last August. And we're growing that into a network of autonomous moves that are happening into Texas, from Arizona to Texas, along I-10, and once we get to Dallas, down to Houston. So that's happening today. We're growing that fleet, which is primarily to allow us to validate the technology. We expect to have, our plan is to have the first driver-out commercial operations, that's hauling cargo, at the end of 2020.
End of 2020.
And we expect to see this scale over the next few years after that into something that is more ubiquitous.
Yeah.
Yeah.
And I think, what one aspect also is that it doesn't hit, tell me if you guys agree, it doesn't hit all roads at once. This is something that starts, particularly because of the mapping, it starts where the maps have happened because there are freight routes there, and it grows as it grows. And so it's different than a mass market kind of truck or car. But let's get into the technology a little bit from a safety perspective, functional safety. And Vijay, if you would speak to this, how do you guys measure, how do you guys get at the safety aspects when you think about launching a product?
Yeah, so I think you touched on two things. One is overall safety, and a specific subset of that is functional safety.
Yes.
So functional safety, many of you might be familiar in the audience already, but it's the idea of ensuring that the vehicle is safe even if there is a fault in the system. So as an example, what happens if the primary computer in the vehicle has a fault or breaks down? So all of our vehicles are equipped with secondary computers that can take over and bring the vehicle to a safe stop. So they're not reliant, if the primary computer fails, they're not reliant on a human being having to suddenly take over and bring the vehicle to a safe stop. That is a backup computer. So similarly, there are backup sensors and there are backup steering systems and braking systems to mitigate any fault that might occur in the system and still be able to keep the vehicle safe. So we focus a lot on the redundancy and what happens and what kind of redundancy is needed to ensure functional safety. In terms of overall safety, that's a much larger umbrella than just functional safety. So we test through a variety of ways. So specifically, we collect lots of real-world driving miles. So I mentioned we have about 10 million miles. Those are collected across a variety of locations within the United States and in different conditions, so different weather, as an example. We also rely a lot on simulation. So we've done about 7 billion miles in simulation. And what simulation allows us to do is take a challenging situation and improve our software and the self-driving system and go back and see in simulation whether the vehicle would have performed well in that situation or not. So every time we update our software, we update our hardware, we can rerun against that tricky situation and understand whether the performance has improved. Not just that, we can actually make the situation harder for our vehicles and say, what if that car that was running the stop sign was actually going 10 miles per hour faster? And so make the problem even harder and see how the vehicles do in simulation rather than trying to discover these things in actual testing. And then finally, we have a private test track. It's like a mock city and freeway driving scenario where the kinds of rare situations that you don't always see even in real world driving, we can create those in our private test track and say, hey, what if there's a crazy construction or a stalled vehicle that happens that suddenly veers into our trajectory. So those are the kind of challenging situations which we might not even see, but we can safely recreate in a private test track and see how the vehicle behaves and then feed that into our simulation again. So those are some of the ways by which we sort of test rigorously to ensure we're building safe systems.
Thank you. It's very thorough. Chuck, what would you add to that?
Yeah, I mean, that covered a lot. It's common practice for functional safety and operational safety. We're following a formal functional safety program, which I'm sure Waymo is as well, that's based on an international standard called ISO 26262. There's also a new standard called SOTIF, Safety of the Intended Function, which we're also following. That's an emerging standard. That helps us do formal analysis of the safety of the system and helps us identify through a formal process where we have to have redundancies in the system. We also practice very conservative operational safety. You saw an example of that where we take over before we let the condition get so bad that an incident could happen. We also have a sort of a closed loop process where the truck operates, it collects data, that data gets pulled back into our systems where we do heavy automated analysis to spot issues, and then we do a human triage, and then we have the ability to do intense simulation of changes, and we use simulators in the regressions for new software releases as well. So we burn many miles before we allow it to get back on the vehicle, and then it comes back to the vehicle for either track testing or highway testing.
Okay, and we'll go to the audience in a second, so please head for that microphone there if you have a question. But one quick response from each of you, if you can speak to the role of AI in your system, because that's a hot topic here at South by. Is it a big part of things?
Yeah, so it is a big part of our system that the software that drives the car uses a lot of machine learning. It's not only a machine learning system, it's a hybrid system comprising machine learning and an engineered system. And we've built what we call sort of the machine learning factory. So all of the infrastructure needed to actually support a machine learning system, the collection of data, figuring out what is the right data that should be fed back into the system, getting it human annotated, retraining the models, understanding the improvements in performance and whether those are sufficient enough that we can now deploy these vehicles back on the roads. So we have this whole infrastructure around that goes in supporting the machine learning that's behind the software driving the cars.
Yeah, and that's a great point. That what we like to say is about 10% of a self-driving truck system is in the vehicle. About 90% is the infrastructure behind it. And if you're doing a self-driving company, if you don't attend to that infrastructure, you're just not going to make it to the end. And Waymo's done a great job in that. And we think that we're doing a pretty bang-up job ourselves.
Okay. Yeah. Well, there's must be 10 or 12 people there in line. So I'd ask each of our questioners to make your question brief. If it's up to you, but it would be nice to know who you are and who your organization is, but it's only if you feel inclined to offer us that. So let's start off. Please go ahead.
Thank you. So my name is Nishan Marks. I'm with the CVG International Airport. So Greater Cincinnati International Airport. We're very excited about autonomous vehicles. I have a few different focus areas. So a comment and a question. First comment, if you want to come and try things out in an area where there's snow, rain, and everything, I welcome it. We are working with a few autonomous vehicle companies. The second, really the question that I'm curious about, because while the Cincinnati Airport is an airport that carries people, we also have the DHL Worldport. It's as big as their space in Germany. We also, while we didn't get HQ2, Amazon, we have their air hub that's coming. So the trucking that's coming in and out of there, we know KYTC, our local Kentucky transportation system, Ohio transportation system. We have this horrible thing called a bridge that everyone's trying to figure out. They can't build roads fast enough. So we're looking at how do we help them with that. How do you feel about roads that are autonomous vehicle only?
Autonomous vehicle only roads. Guys, quick thoughts on that?
I think it'd be great if somebody built an autonomous vehicle only road.
Like, sure.
Yeah, I'll echo that. I think it's also important to note that we are building the technology and the trucks to work with the roads of today.
Yeah.
So these roads are have been built for human driving over hundreds of years. Typically, like in general, they evolve gradually, and the transition happens over a number of years. So we can't be reliant on those transitions happening. So we've built them to be able to drive today's roads. Now, having said that, any improvements that are made to the roads, even for human driving, will benefit self-driving as well. And I think what you're pointing out is one extreme of that, which is saying, hey, let's make it very simple for you and have AV-only roads. And I echo that it'll simplify the driving environment even further.
And I'll just add very briefly, in my 20 years of consulting in this space, the idea of truck-only lanes, automated-only lanes, has been talked about, and never got past the talk, because you're talking public money and the justification is tough. But it'll come eventually.
I think in the situation that we're in between Cincinnati, Ohio, and Kentucky with the Brent Spence Bridge that goes straight between 71-75 corridor between Michigan and Florida, We have to do that, and that's why I welcome that conversation from you guys more often.
Yeah, it should continue for sure. Let's go with...
come see me after. I'd like to talk with you about the airport.
Likewise. Thanks for bringing that up.
All right, sir, please go ahead.
Hi, my name's Mike Halem. I consult for Rocket Power, which is my own consultancy, and I'm in the space. First, just addressing what she said very quickly, there are certain pieces of infrastructure we can't build more. I live in New York, the Lincoln Tunnel. I'd rather it be all, if I have to commute through it, all self-driving, so because the cars can shuffle a lot better than manual people can shuffle, and we can get more throughput so people get to work faster. So I've got two quick questions. First, for Vijay, I saw the car with nobody in front, but I'm assuming that you monitor that from a remote control center, at least during earlier phases of testing, so that way somebody actually could take over if they didn't see something they like. It seems pretty aggressive to just go, I'll say, naked without anybody but the vehicle running it. And the second one was for Chuck. I like what you're doing, but I saw it just like start out straight. Well, most of these distribution centers have loading docks, and where we put everything in the giant Amazon warehouse using a name that's not used. So do you have that technology also to go loading dock to loading dock is really what I'm talking about. So two questions. Thank you.
Okay. DJ, you want to start?
Yeah, thanks for the question. So I want to clarify here that when there's nobody sitting on that front seat and we are operating fully self-driving vehicles, nobody else is going to take over that car. The car is responsible for the driving the entire time, and it's going to bring itself to a safe stop. So there's nobody waiting to suddenly take over control or jump from the back seat to the front seat, none of that. The vehicle will bring itself to a stop, and that's the big difference between the higher levels of autonomy and the lower levels of autonomy.
Good.
And just to add to that, before I answer the other question, I think we both companies share the value that a remote control technology can't be made safe because it's over RF and you can easily jam RF. So you have to make sure that the system can operate in the face of even that failing. And so that's the essence of level 4 autonomy, is the vehicle has to be able to handle all of the conditions that are required of it. Now, in our case, we are monitoring, but we won't take control of a live vehicle.
Right.
It's on the highway.
And the other question?
The other question is regarding loading docks. We do have a plan to go completely to the dock. It's not in our first release, but we have the technology. We know how to do it. We're just not, it's the minimum viable product idea.
Yeah.
So we do have the tech. We know how to do it. We're just not releasing it in the initial release.
Okay.
Thank you. I like what you're doing. And just one other comment. People worry about the jobs. I ask how many people have to die so that way a trucker can keep working. We're killing now thousands of people on the road with manual driving, and it's a tragedy, and it's not
Understood.
just economics.
Thank you. Next, please.
Hi, my name is Simon Chen. I'm a technologist, but I'm not in this industry at all. Thank you for the great presentation, first of all. And my question is, do you still require human monitor in your trucks? And when do you think you'll be able to remove that monitor element? Thank you.
Yeah, so in our trucks, we do have a trained driver monitoring the truck. And our plan, I think, I mentioned the various ways by which we ensure the safety of the system. So really, safety is our top concern. So we will only remove that trained driver from that driver's seat once we are convinced that the truck can fully drive in all situations and bring the vehicle to a safe stop.
In our case, it's similar. We have a specially trained professional driver behind the wheel, and as you saw in the videos, they don't touch the controls unless they're required to. We also have in the right seat a safety engineer who's monitoring the systems. This allows the driver to keep eyes out of the vehicle to operate observing conditions, with the safety engineer reporting to the driver what the computer is perceiving. And in addition to that, the computer itself verbalizes its intent before it takes an action when that's possible and makes sense.
All right.
And we also will be removing them when the time is right, but we do expect to monitor forever, to monitor the fleets as they're operating autonomously and provide certain services to those operating fleets, including a rescue service when a vehicle breaks down, a refueling service, and other things.
Mm-hmm. Okay. Thank you, sir. Next question.
Hi there, my name is Jillian Brown, and I work for an innovation firm based out of DC. And my question for you is more about the future role of truck drivers, and just as autonomous trucks become more mainstream, what is that evolution of the role? Is it total elimination, or is it more of a specialized role? How do you see the future of it?
Oh, I'll start by saying, for the first era of driverless trucking, it will be taking care of all of those driverless trucks that are parked with no drivers. So that'll be quite a while before we hit that capacity. But then in terms of the evolution of truck drivers, either you want to comment on that?
So we see, especially for the functions like monitoring the autonomous vehicles that are on the road and providing rescue and refueling and other value-add services, we think this is a great role for truck drivers to participate in, because they understand the world that trucks are operating in. They understand when conditions are getting bad, and perhaps vehicles could choose different routes or whatever. We think that this is a good evolutionary step for someone who might be displaced, but we don't think that displacing human drivers is something that's going to happen in the short term, because there are 50,000 missing drivers today.
Yeah.
And in a few years it's going to be 175,000. And the median age of the driver in 2015 was 49. This year it's 55. This is a pool of jobs that aren't getting replaced. Millennials aren't jumping into truck driving as a thing. So
Yeah. Okay. Yeah. Well, let's see if we can take just a couple more. Please go ahead.
Hi, I'm Minkin Zhang from Invesco. Curious on your thoughts on how this will impact the change for business models for the third-party logistics companies. So from what I understand, third-party is more of an asset-light platform, and the drivers themselves are the ones that actually own the trucks. So if in the future, let's say a XPO wants to take 30% of their fleet and make it driverless, do they have to now own the trucks?
Yeah, I think it's still an open question. To your earlier statement, there are different models. So some third-party companies and private companies like the Walmarts and Pepsis own their own fleets as well. Some 3PLs are asset light, and I think as they're learning more and more about this technology through the pilots that we and TuSimple are doing, that's the computation sort of they're doing in their head, which is saying, how is my business going to evolve once this technology is everywhere? So I don't think I can personally say what the answer is right now, but hopefully over the next year or two that'll become clearer to us.
yeah.
Okay. Yeah. Okay. Next, please.
Hey guys, I'm Josh. I'm an industrial design student at the University of Houston. And I'm wondering, so you were talking about the levels of advancement. We're at 1, 2, and 3. Are we there mainly because the technology isn't advanced enough, or social acceptance isn't accepting enough? And if it is social acceptance, how can we design cars for that acceptance?
So both for level 4, I think we are working hard towards making the technology ubiquitous. But you bring up an important point, which is public acceptance to this is super important as well, because we're driving on roads. These vehicles are sharing the roads with them or driving in their communities. So we take that very seriously. We have a campaign called Let's Talk Self-Driving, where we partner with institutions such as the National Safety Council to educate the public about these vehicles. So it's letstalkselfdriving.com. So we've done a series of initiatives in Phoenix, Arizona, where I showed the video from of our self-driving vehicles, and our hope is to expand that dialogue to become a national dialogue as we grow our presence in other areas as well.
And we agree. The technical side is something that we're trying to advance and reach a point where we can do this. We're not quite there yet. It's not just us; it's our partners that are building hardware and building trucks. We all have things to do to make this ready, and we think it's going to be a couple of years minimum to achieve that. And in terms of public acceptance of trucks, our goal is to make the trucks as invisible as possible on the highway. That they operate. You wouldn't tell, other than spotting that there's a sensor, that it's operating any differently, other than operating perhaps more safely than a human driver. And we've had riding in our vehicle an industry expert who described our system as polite. And that's a goal, to be polite.
Yeah. Okay. We're going to take one more. We're right at the end of time, but please go ahead.
Hi, my name is Dan. I'm with Koito. We're a tier 1 headlight supplier. I was wondering if you had any projections for how many trucks you expect to have on the road beyond 2020.
Future projections of number of automated trucks on the road.
Yeah. This is a tough number to project.
Yeah.
I know that I've had conversations with major fleets who basically said they would be willing to buy trucks by the thousands the moment that we reach this point where it's ready to go. But that's going to be significantly limited by regulatory approvals at state by state level. So I think we will see a growth that is impressive in the mid-20s. But
yeah, I guess I'll add to that. We didn't talk about return on investment that much, but the business case is absolutely eye-popping. So once this is seen as ready by the existing freight companies, it's going to move fast. So thank you for that question. I'd like to thank you for all your questions and your attention. And Vijay and Chuck, thanks for great presentations, great comments.
Likewise, Richard.
Thank you.
See you.